11.6, we're going to look at quadratic functions and their graphs. And what we're going to do is we're going to find a distinct pattern in this graphing technique that it's going to be graphed just as fast as we graph a linear line, y equals mx plus b. In order to graph that, you have to have a starting point and the slope takes you to other points. So we're going to go for the same thing. We're going to need a starting point and we have to identify a pattern and how to plot these points. All right, so these graphs, they're going to have a vertex, which we'll describe, a LOS, which is a line of symmetry. All right, we're going to find a counting pattern for your y coordinates, and your max or min value is going to be this y coordinate of your vertex. So y equals x squared, basic form. Let's plot points. So I'm going to run through this real quick. You can pause it at the end and then fill in your points. Well, we're going to start with 0. 0 squared is 0. That gives you the point 0, 0. 1. 1 squared is 1. That's the point 1, 1. And we're going to plot these points as we find them. 2. 2 squared is 4. That's the point 2, 4. 2, 1, 2, 3, 4. 3. 3 squared is 9. That's the point 3, 9. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 4 squared 16, 4, 16, we'll plot that. 5, 5 squared is 25. 5, 25, I think it's all the way to the top. So this is the right-hand side of my parabola. The point down here, this lowest point, 0, 0, is my vertex. The line of symmetry is this imaginary dashed line that goes through the vertex, and this curve has to flip over that symmetrical line. Because if you go back over here and you take negative 1 and squared it, you still get a positive 1. Negative 2 squared, 4, negative 3 squared, 9, negative 4 squared, 16, negative 5, positive 25. So this point flips over the line of symmetry to here, 1 to the right, 1 to the left, 2 to the right, 2 to the left, 3 squares to the right, 3 squares to the left, 4 to the right, 4 to the left, 5 to the right, 5 to the left. And then we draw in our curve. Now, if you have a big gap between points, I know that's difficult to draw within the rectangular boxes right there, those squares. So you can connect these with a straight edge. I'm okay with that until you get to the vertex. This has to be a curve. And I'm telling you right now, this is where I'm going to be picky. From this point to this point, everything has to stay in that column of 3 squares. Column of 5 squares. They've got to stay inside those column of squares. If you go out and come back in, it's no longer a function because it won't pass the vertical line test. Now, to look for the pattern in your x and y's, we're going to look at these coordinates here of just the right-hand side. Starting with the vertex 0, 0. I go to 1, 1. 1 goes to 2, 2 goes to 3, 3 to 4, 4 to 5. All my x coordinates are increasing by 1. That's important. This only works if your x coordinates increase by 1. Then we're going to check how do your y's differ. 0 to 1, 1 to 4, 4 to 9, 9 to 16, 16 to 25. That's a 1, that's a 3, that's a 5. Hey, wait a minute, it looks like it's odd numbers. That's a 7. Yes, it is. It's odd numbers. If you wanted to double check, the next odd number would be 11. And 25 plus 11 is 36, which is 6 squared. So we have a distinct pattern here. From your vertex, you will always go 1 to the right, up the first odd number 1. 1 to the right, up 3. 1 to the right, up 5. 1 to the right, up 7. 1 to the right, up 9. All we have to do is graph the right side, because the left side, we just flip over that vertical line of symmetry, and we get the left-hand side of your graph. So as I said, this is almost as close as graphing y equals mx plus b. I need a starting point. I have it, vertex. I need a pattern. Well, instead of the slope, rise over run, we're going to go one right, up one, one right, up three, one right, up five, one right, up seven. That's from point to point. Once you have all your points that fit on the graph, we flip them over the line of symmetry, and we're done. If I looked at y equals 3x squared, start with the same zeros. 0, 1, I'm going to use the same points. 0 squared is 0 times 3 is 0. 1 squared is 1 times 3 is 3. Plot that point. 2 squared is 4 times 3, 12. 2, 12. Plot that point. 3 squared is 9 times another 3 is 27. Well, we had 25. That's already off the graph. But I'm going to still fill in the table. I'm not going to plot those points. They don't fit. I'm just going to work this table to show you the pattern and how it's been changed. Line of symmetry, flip them over. One square to the right for that point, 1 to the left, 2 to the right, 2 to the left. We have a skinnier parabola because we're multiplying by another value to make your y's bigger. So again, there's my 1's. Now the pattern in my y's, 3, 9, wait a minute, 15, 21. What on earth? Hold the phone. 27. What happened to my 1, 3, 5, 7, 9 pattern? It's still there. Break these numbers down. This is 1 times 3, 3 times 3, 3 times 5, 3 times 7, 3 times 9. See, your 1, 3, 5, 7, 9, they're still there. They've just all been multiplied by 3 because this 3 is being multiplied to your x squared. So that means what we're going to say now is that 1 to the right up 1 times 3, 3. 1 to the right up 3 times 3, 9. And that's how we get our graph, and we flip it over. So your pattern is now complete. From your vertex, we'll go 1 to the right up 1a. A being the value or the coefficient multiplied to x squared. 1 to the right up 3a, 1 to the right up 5a, 1 to the right up 7a. All right, on that same graph, we plotted those same two on one graph, that's fine. Now we're going to do this one, but we're not going to make a table. My vertex is still at 0, 0, but now my a is a 1/2, so I'm going to plot my vertex. I'm going to go 1, 3, 5, 7, 9, and I'm going to multiply them all by 1/2. So 1, 3, 5, 7, 9 times 1/2 gets you 1/2, 3 halves, 5 halves, 7 halves, 9 halves. So 1 to the right up 1/2 square. 1 to the right up 1, 2, 3 halves. Now I'm counting half squares. 1 to the right up 5 halves. 1, 2, 3, 4, 5. 1 to the right puts me right in the middle of the square, up 7 halves. Whoops, lost my cursor. 1, 2, 3, 4, 5, 6, 7. Plot my point. 1 to the right up 9 halves. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 halves. Well, let's see. Let's see if we get 11 halves in here. 1 to the right up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, there's 11 halves. Line of symmetry through the vertex, flip them over. 1 square to the left, 2 squares to the left, 3 squares to the left, 4 to the left, 5 to the left, 6 to the left. Draw my graph. And you should also notice that my arrows, they stop at that last point. Don't go past it. If you accidentally turn in, cross another point too soon, I will take a point. So just stop right there. No reason to go any further. Y equals negative 2x squared. Okay, vertex is at the origin right there, 0, 0. Take your 1, 3, 5, 7, 9 multiplied by negative 2. Negative 2 times 1, negative 2. 3 times negative 2, negative 6. 5 times negative 2, negative 10. Negative 14, negative 18. Will we use all those? We don't know. So we're going to go 1 to the right. Now we're going to look at the bottom half of the graph. Because these are negative, we don't go up. We now go down. 1 to the right, down 2. Plot a point. 1 to the right, down 6. Plot your point. 1 to the right, down 10. That's way down here. Plot your point. I don't think 14 is going to fit. All right, flip it over your line of symmetry. We're 1 to the right, now 1 to the left, 2 to the left, 3 to the left. Draw straight lines until you get to your U. Right here is a curve. Arrows at those last points, that's where they should stop at. Call it done. All right, now the next thing we're going to work on is how can I tell what happens if my vertex does not start at 0, 0. So that means we're now going to move left, right, up, and down. So if I take my x squared and I add a 4, this is what I envision happening. All my y coordinates get 4 bigger. So if this was my y equals x squared, all those points have to shift up 4 squares. And there's my graph. Now, I'm not going to draw this graph just to graph this graph. What we're going to do is say, hey, look, I see this plus 4. It's going to change my vertex. It's going to move it up 4, plot that point. There's a 1 in front of my x squared, so my pattern from here, 1 to the right, up 1, 1 to the right, up 3, 1 to the right, up 5. Flip it over that axis of symmetry, there's my graph. If I have y equals x squared minus 7, now the red graph is going down 7 squares. So all those points down 7 squares, draw your curve. But again, we're not going to draw x squared just to shift it down. You take your vertex at the origin, you move it down 7 squares from here. 1 to the right, up 1, 1 to the right, up 3, 1 to the right, up 5. You can flip it or you can do it in reverse. 1 to the left, up 1, 1 to the left, up 3, 1 to the left, up 5. Whatever you want to do will work for me. All right? So anything after the x squared, plus 4, we go up 4. Minus 7, we go down 7. How do we get this thing to shift left and right? Now my plus or minus is inside a set of parentheses before I square it. After it's squared, up and down. Before I square it, left and right. So you would think with x minus 6 that we're going to move this to the left 6. Actually, you're going to the right 6 squares. All those points are going to the right 6. Now, how did I know that? Well, remember, if this is my vertex and we're shifting left and right, the y coordinate of 0 cannot change. So what value must I put in here for x to make this into a 0 squared? It's got to be a positive 6. So we go 1, 2, 3, 4, 5, 6 to the right from here, 1 to the right, up 1, 1 to the right, up 3, 1 to the right, up 5, 1 to the right, up 7. This is my new line of symmetry where the vertex is at. Flip them over. Graph is done. Y equals x plus 5 squared. Okay, now we got to go left 5. To turn this into a 0, think about solving it for x by setting it equal to 0. X equals negative 5. I'm going 5 to the left. All these points all go to the left 5. Well, we're just going to have the vertex go to the left 5. From there, 1 to the right, up 1, 1 to the right, up 3, 1 to the right, up 5, 1 to the right, up 7. Flip it over the line of symmetry, which goes through the vertex. And there's my graph. So what we're going to do now is we're going to combine left and right shift with an up and down shift. When we combine those two transformations, that's what we call it. We call this the vertex equation. Y equals a times the parentheses x minus h squared plus k. We want to see something in the parentheses before we square it and after. This vertex, some authors call it the standard form, a lot of people call it vertex form. This will tell you where your vertex is located at. It's at HK. All right, just again, quick reminder. Opposite of this sign, plus. Minus to a plus. Outside face value. And then your A being multiplied to the parentheses, that determines how you change your 1, 3, 5, 7, 9 pattern. So if I was asked to find the vertex and pattern before graphing, find the X, change the sign, -6, -5. That's my vertex. Again, remember, always sign change from inside the parentheses to the actual point. All right, plot that point. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. There's my point. Now my pattern, there's a 1 in front here, so that's just going to be 1, 3, 5, 7. That 1's not going to change my pattern. So from here, 1 to the right, up 1, plot a point. 1 to the right, up 3, plot a point. 1 to the right, up 5, plot a point. And let's see if 7 fits. 1 to the right, up 1, 2, 3, 4, 5, 6. No, it doesn't fit. Do not add an extra square. We'll just work with this. Line of symmetry, right through the vertex. 1 to the right, 1 to the left, 2 right, 2 left, 3 right, 3 left. Draw your curve. Arrows stop at those points right there. Again, I don't want you to keep going up. I'm supposed to go up 7, but if all of a sudden I crossed too soon, ding, -1. Or your curve bends inward, ding, -1. All right, next one, y equals negative. Okay, that's going to be a -1, don't forget. Find the x, change its sign, +4, sign on the outside, +7. That's my starting point. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Plot your vertex. Now that -1 is going to change your 1, 3, 5, 7 to -1, -3, -5, -7. This is going to open down. 1 to the right, down 1. 1 to the right, down 3. 1 to the right, down 5. 1 to the right, down 7. I keep going to fill the entire graph with points. Line of symmetry, you're more than welcome to put in a dashed line. Flip it. 1 right, 1 left. 2 right, 2 left. 3 right, 3 left. 4 right, 4 left. There's my problem. This has to be a curve. These can be straight lines, arrows at those endpoints. Next, we have y equals 2. There's your A. X -4. That's going to be my x coordinate of the vertex, -9. Find the x, change the sign. +4, -9. 1, 2, 3, 4. Down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my point. Oops, A is 2. Take your 1, 3, 5, 7, multiply them all by 2. 2 times 1, 2. 2 times 3, 6. 2 times 5, 10. 2 times 7, 14. 1 to the right, up 2. 1 to the right, up 1, 2, 3, 4, 5, 6. 1 to the right, up 10. Can't get anything else in. Line of symmetry, flip it over. There's my graph, arrows at the endpoints. Y equals -1/2, x plus 2 squared plus 3. Find the x, change the sign. -2, keep the +3. To the left, up 3, plot a point. Well, now my A is -1/2. I multiply that to 1, 3, 5, 7. -1/2, -3 halves, -5 halves, -7 halves. So 1 to the right, down half a square. 1 to the right, down 1, 2, 3 halves. 1 to the right, 1 halves, 2 halves, 3 halves, 4 halves, 5 halves. 1 to the right, down 7 halves. 1 half, 2, 3, 4, 5, 6, 7 halves. Let's see, 9 halves, will that fit? 1 to the right, down 1, 2, 3, 4, 5, 6, 7, 8. 9 halves fits. line of symmetry, flip them over. Draw my curve. There's my parabola. We're done. Now, I want to make a point here. When you're graphing in more, it might not be possible to go one to the right, down a half, and get it to actually plot that point. It might count by those full squares, so you can't do half a square. So here's a nice little trick. If my denominator is a 2, then add the first 2. -1 half, -3 halves, -4 halves. So adding the 2 rights, 1, 2, down -4 over 2 is -2, down 2. Take the next 2 fractions. -5, -7 added together is -12 divided by 2 is 6. So from this point, 2 to the right, because I'm doing 2 moves, down 6. 1, 2, 3, 4, 5, 6. So when you are in your computer, you're asked to graph, you'll see your parabola. It'll have a point on the vertex and another point anywhere else. You must plot the vertex first. And if this is an integer, 1 to the right, down 1. It's a fraction and you can't get it to go half a square. Take the first 2, add them together, 2 to the right, down 2, plot that point, and puts in the whole parabola. Now, if this was 1/3, it would be 1/3, 3/3, 5/3. You add the first 3 fractions. That will simplify to an integer, and you now go 3 squares to the right, down however many that fraction simplified to. Next, here you will be given graphs. You have to come up with the equation. So you have to find the values for A, H, and K. So the first and easiest thing to find is the vertex. There's my point. So to the left, 1, 2, 3, 4, 5. Up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -5, 10 is my point. Okay, that's my H. So x minus a negative, remember sign change. That'll be x plus 5. And your K is your y coordinate plus 10. Now to find your A value, from your vertex you go 1 to the right, and I go down 1 full square, so A is that distance right there, it's -1. I put it in, and I am done with my equation. All right, hit the pause button, try this one on your own. When you're ready to check with mine, hit play. All right, welcome back. So again, A, H, and K, you plot your vertex. 1, 2, 3, 4, 5, 6 to the right, down 2. I'm at 6, -2. This is your H, this is your K. So x minus a positive 6, x minus 6, minus 2 is my K. Find A, start at the vertex. 1 to the right, up 1, 2, 3. It hits perfectly right there. So A is 3, we'll put 3 in front of our parentheses. 3 times the binomial x minus 6, that's squared, minus 2. There's my equation. We're all good. And that wraps up 11.6.